Well, it seems a little strange, but thank you, Kai, for introducing me to this portion of Day of Discovery. We hope everybody's having a great day so far. As I record this, we're going to do something different. Obviously, we've never done this at a Day of Discovery before, but we've been talking about blue, methylene blue, with the different colloidals that we have in methylene blue. One of the things that I'm going to show you, and we're going to try and do this in a documentary fashion, right? So you can see in one take, bloopers and all, everything that we want to show you here. One of the most powerful things that I believe is in the blue product is the fact that it's called what's called a redox agent. A reactivating, a carrier, so to speak, of oxygen throughout the body, meaning it can do it over and over again. Specifically as it relates to the mitochondria. Now, we've talked about, and we'll continue to talk about when we talk about blue, how it is a powerful tool with helping the mitochondria function with just great energy production and giving it the resource it needs in order to do that. What I'm going to show you right now actually is a very interesting experiment to show how methylene blue actually, you can see it reactivate. You can see this redox function taking place. We're going to start. We have 3 ingredients. We have the distilled water, we have glucose, and then we have this cleansing agent, these particles that help make sure that there's no contaminants in the water. So we want to make sure we have a great environment to say nothing else is influencing this. So what are we going to do? We're going to start by taking our distilled water, and we're going to add it. We're going to add about 300 ml. Or so. This doesn't need to be that specific, but we're adding some distilled water before we bring in the rest of the ingredients. Okay, so we're happy about that. I think we're just shy or just over 300 ml. Next, we're going to take this potassium-based cleansing agent, and we're just going to add it through this funnel. So we'll add these particles in. And you'll see all of these, they dissolve in water. And as they dissolve, they act as the cleansing agent that we want to make sure that there is just nothing unwanted, no extra particles. And in theory, with a distilled water, we should be experiencing that. But obviously, with any exposure, you're going to run into a challenge there. And so we're just going to make sure. Sometimes we have to shake it up a little bit to get all of the potassium chloride through. Like I said, bloopers and all, we get everything to go through. There we go. No problem. It does give this kind of reddish, and you'll see that carry through as the cleansing agent. Now, this isn't going to do anything beyond just really remove any extra particles and make sure that they have no influence at all. There we go. We have everything in. The next step is we need to make sure that it's dissolved. And so we're just going to take this potassium-based cleansing agent and shake it up. While it's shaking up, so what is one of the things, and just to reiterate, hopefully, in this process of the value of a redox agent, meaning a reactivation or a carrier of oxygen and a carrier again and again of oxygen to the mitochondria. Well, the oxygen in the mitochondria actually is a primary tool for bringing in the enzymatic exchange process in that chain reaction, for bringing protons back in and actually creating the energy through the electrons for the cell to use. And then obviously we all know, we've all heard it since grade school, the mitochondria is the powerhouse of the cell, right? And well, when the powerhouse is working, everything's working. When it isn't working, we actually, not only is everything not working, but we're actually creating reactive oxygen species, which is a challenge. Looks like we have everything dissolved now. And so because this is dissolved, we can now add our glucose. Glucose is oxygen hungry. It is an oxygen hungry ingredient. And so we're just going to, and it's really sticky and slimy. And so we're just going to put it on here. It's going to fall to the bottom. But because it's oxygen hungry, it's just bringing in whatever oxygen is available, right? And so we see that happens as it dissolves in the water. It's already taking oxygen that's available to it. But the demonstration that we're going to see is actually the power of methylene blue in delivering or making more oxygen available to the glucose to use and absorb and extract. So we're going to add the rest of our distilled water here. And you can see the glucose is going down, and it's going to do it through this experiment. We may not even fully dissolve all of it all the way through. But now we have plenty of our distilled water, we have our cleansing agent, we have glucose. Now the only thing left to add is the methylene blue, our blue product. And so we're just going to we're going to pump into it, get the pump engaged, and then we're just going to add a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? We'll start with 10. The other thing we want to do is we're going to seal. We don't want more oxygen available, right? So otherwise it's going to be a never ending. In fact, with this experiment, what we're going to see is a reactivation of methylene blue by oxygen over and over and over again until there's either no glucose or there's no oxygen left or there's no methylene blue left. So let's just kind of stir this up and do exactly what, hopefully you've been warned. If you have your samples already, and I believe by this point you probably, if you haven't sampled blue yet, you should get some samples. But the idea here is it is blue. It is exactly blue. It will stain your clothes if you get it on it. So be very careful when you use it. How I have been using it for the last months is I've actually just taken it, put it in my mouth, shot it to the back of my mouth, and did my 10 pumps, and I have it in my system. So blue, you can see, it automatically, it gets in, it discolors the entire water to a blue-looking material. And so because it is this really strong, rich blue, it should be fairly clear that, it is active. It has its purpose, that whatever makes up its molecular structure is evident in itself, in and of itself. And what we need to do now then is as we mix it up, so the more I mix it up, the more oxygen it can take from not only the air, but also from the H2O, right? H2O is going to be a carrier of oxygen, of course, in and of itself. That is the structure of H2O. It has oxygen in it. So what is methylene blue going to do? What is blue going to do? Well, as it starts, and what we're going to see is it's going to start to deliver more and more oxygen to that glucose. It's going to give it away. After it gives it away at a standstill, it's going to then be in need of picking up more oxygen. As it's in need of picking up more oxygen, it will then need to be in movement. And think about like your body system, right? You take methylene blue, and we've talked about the nano qualities of methylene blue and blue itself, right? Not all methylene blue is nano, but Solex's blue is nano. It has been really broken apart to smaller and smaller structures, so it's massively absorbable, and then into the bloodstream, so that it can then go in movement throughout the body, picking up oxygen. And as it picks up oxygen, it's going and delivering that oxygen to cells that are in need of oxygen. And as we pass by a cell, the mitochondria in that cell need oxygen in order to produce the energy it needs for that particular cell's function. It is handing off oxygen. As it hands off oxygen, it actually impacts the structure of methylene blue. And so it needs to stay in motion, and as it stays in motion, it can scavenge for other oxygen, pick them up in the molecular structure, bind with them temporarily to deliver it elsewhere. That is exactly what's happening when we're looking at methylene blue in and of itself. Now, this is staying blue right now, and so what we're going to do is kind of look at this over time for just a minute here as it sits. And as it sits and as it eats up the glucose is going to pull oxygen in, and it is actually going to take the color out of blue. Now, as you see, as we time-lapse that and make it a shorter view, to take the few minutes that it took to get the clearing of the blue, you see that it's no longer methylene. I mean, the methylene blue is still there. It just no longer has the color. But the question is, okay, if it's a redox agent, it should be able to reactivate its properties as it picks up more oxygen from the water. So then that's the next step of this experiment is, can methylene blue pick up more oxygen and bind with it and carry it again, right? And deliver it to more of the glucose. So then what do we do? Just like methylene blue passing through the bloodstream throughout the body, it's in movement and it's passing by oxygen in order to pick it up. And so we're just going to do the same thing here. If we start to move the methylene blue, what happens to it? It begins to pick up oxygen. As it picks up oxygen, it is evident in the coloration, and we can really agitate it if we want it to really pick up a lot. And so it picks up the blue again, and then it's going to do that over and over and over again. Think about what it's doing inside your system. Picking up oxygen, delivering it to the cell. Picking up oxygen, delivering it to the cell. It can do it over and over again until the methylene blue is spent or until there's no more oxygen available for it to deliver. Or in this case, there's no more glucose to receive it. Now, the one thing we did see as we've done this experiment a few times is that methylene blue does have a bioavailability. Most micronutrients have a bioavailability of about 12 hours. And we knew that methylene blue definitely is going to be within that window because there's a point at which methylene blue is no longer able to reactivate, even if you introduce new oxygen to it. Like I could take off this cover, expose it to more oxygen, and it still will not revitalize as blue. But for now, see, we're almost, the tinge of blue left in there, but you can see obviously it's changed its property. We'll do it again. Let's see. Just one more time in this experiment, just for fun. Yep, there it goes. Methylene blue, a powerhouse of oxygen delivery to the mitochondria within the cell to allow the powerhouse of the cell to function at its optimal level. That's what blue does. That's what blue does so powerfully. And it doesn't just do it because it's methylene blue. It's the colloidal gold, the colloidal silver, the colloidal copper, helping maintain its redox function in the bloodstream over and over and over again in that environment where it can deliver over and over again oxygen to the mitochondria so that that power is available and is a resource that is much needed. I hope you like the experiment. I hope it gives you some visualization to what is actually happening in your body when you do those 10 pumps, in your throat. But the one thing I want to impress upon you is that nanotechnology is in effect here as well. That it can do it quicker and faster and is more available and is more expressive because it is magnified in its reach, because it is broken down to the smallest part we can break it down to right now, and that is through nanotechnology. So everyone, I hope you enjoyed the demonstration to see what blue can do for you over and over and over again. We love it. We're big fans over here, and this is just one other way for you to see how it actually works within your body.